drought. Okay. I just have to click a button here since we're recording this. Here is what the global warming so far looks like. And this map was made by colleagues at NASA, where they took global thermometer records that stretch back as far as the 1880s. And they could make a global map of how temperature has changed at every spot around the planet where we had thermometers back in the 19th century. The gray areas at the highest latitudes, north and south, we didn't have thermometers back in the 1880s. So that's not colored on this map, but everywhere else, you can see that the warming has been occurring, except in the North Atlantic, where we predicted it wouldn't be because of ocean circulation changes. And what we know is since the 19th century, when we started getting thermometer records, ever since we started getting thermometer records in the polar regions, those areas are actually warming more than just about any place on the planet, particularly in the North Polar region. So the global warming has been about 1 degree C, almost 2 degrees F, and it's not uniformly distributed. It's greater over land and at high latitudes, which of course is where we live, over land, right? We live on land, continents. So the warming in the West has been about the global average, a little more than the global average. In some places, like in the upper basin of the Colorado River, it's been almost double the global average. And of course, as you go up into the polar region, it's been quite a bit more. And the warmest 7 years in the planet's history since we had thermometers have occurred in the last 7 years. So each of those years has been one of the warmest 7 years. Okay. Global warming, as I said, has been about 1 degree C so far. And remember that number, because when we talk about climate change in the future, you can, in your mind, think about the climate impacts we're getting now, and you can just multiply those by some number, depending on how much more we warm the planet. And remember, I said it's really important to understand that warming is driving a lot of what we're going to talk about today. And that's important because we know with near perfect confidence, as long as we continue to put greenhouse gases into the atmosphere, it will continue to warm. In other words, as long as we put more CO2, primarily from fossil fuel burning, or methane, also mostly from fossil fuel production and burning, not burning as much as production, and other greenhouse gases in the atmosphere, it will continue to warm. So if we want to stop these climate extremes that we're going to talk about today, things like drought, we want to stop them from worsening. Things like wildfire, we want to stop them from worsening. We have to stop the emissions of the greenhouse gases into the atmosphere. Number one culprit, if you remember nothing else, is burning of fossil fuels for energy, for transportation, for a lot of other things in society. Just to jump ahead a little, as we have all the solutions to do that, probably less cost than fossil fuels. But of course, it takes a heck of a lot for a whole global society to change their energy basis, how we get our energy. But right now, it's the fossil fuels that are causing this problem, the number one cause. Okay, so here we're going to get into a little science, and I don't like getting too technical in these talks, but this is an important one to realize. As the atmosphere warms, remember, we know it will warm with almost perfect confidence as we put more greenhouse gases in the atmosphere. As it warms, it can hold more moisture. And this is something we knew decades ago. We predicted it would happen. It is happening. And that affects everything in the hydrologic cycle, which is something, if you're taking an earth science class or a geology class or an environmental science class, you know it's a pretty complicated thing. It includes rain, of course, and snow, but it includes all the things in this diagram that I'm showing you. Evaporation, evapotranspiration. We'll talk more about what this means. And runoff into rivers, runoff into lakes, runoff into the ocean. All of these things are sped up in a sense because the atmosphere now has more and more moisture. Okay? So I'm going to try and talk to you and convince you today of what kind of impacts this has. The most important one to me, the one I've been studying on 5 continents, has to do with drought. And of course, when we get drought, we have a lot of very serious consequences. It can be agricultural consequences, hydrologic consequences, not enough water. It could be ecological consequences. It could really affect our natural vegetation. We're going to talk about all of those consequences. But the important thing to realize here is as the planet gets warmer, where the conditions are not ripe for precipitation, rain or snow, the atmosphere is demanding more moisture than it used to. That means it's sucking more moisture out of the ocean, if it's over the ocean, or out of the land surface and vegetation, if it's over land. So bingo, think about this. Why are we getting such a severe drought in California? It's partly because it hasn't rained, and it's partly because it's so darn warm now compared to the way it used to be. So if you're looking for an analogy, think about a gardener. Maybe you've all been, in your family when you were kids, or still today, you garden, and you have a very warm day, a very hot day in the summer. And all of a sudden you notice your plants are wilting because you didn't water any extra. But those plants need more water on those hottest days because the water they have in the soil and in their plant tissue is being sucked away by the atmosphere. And that's essentially what's happening in drought. And you'll see in a minute how that affects some things we really care about. Okay. I recently wrote a paper with a fish ecologist about fish in the Southwest, including Southern California, and how these fish are going to be affected by climate change. And it is a very disturbing story because in a drought, what happens to water bodies? They shrink, they disappear, they flow less. And that's not so good for aquatic systems, in particular fish. And as long as we keep putting greenhouse gases in the atmosphere, these aquatic systems are going to suffer more and more in the Southwest, including in California. So let's look a little deeper into why that's true, okay? We know the atmosphere can hold more moisture as it warms. It's warmed a degree globally and a little more over land in North America. So that means it can hold more than 7% more moisture. And if it's not raining, it's sucking moisture away from the land surface. Where's that water going? Where's it coming from? Okay. So that's what we're going to look for. It's going into the atmosphere. Where does it get it? One of the most obvious that everyone can probably relate to is more evaporation. As it gets hotter, you get more evaporation. So generally, about 10% of water in a reservoir, whether it's in the Sierra Nevada or it's over in the desert, the interior deserts on the other side of the Sierra Nevada, say on the Colorado River or the Rio Grande, about 10% of that water just disappears due to evaporation. There's a bigger term though, and that is evapotranspiration. And I really wanted everyone here to really know what that is, if you don't already. And again, going back to the gardening analogy, the reason your plants start to wilt on really hot days in your garden is because the atmosphere is demanding more moisture, and it's getting that moisture out of the soil, via the plants. So plants actually have teeny little pores in their leaves, and that's how the CO2 gets into the plants for photosynthesis, and the oxygen gets out of the plants for us to breathe. Well, when the gases are exchanging through the little pores in the plant leaves, it's also allowing moisture to escape. And that is evapotranspiration. And there are other things going on. For those of you who like to ski and you ski in the spring, you can see the snow just disappearing on a really sunny day. And that's because the snow is turning into water vapor in the atmosphere directly from the snow. That's called sublimation. And there are other factors going on here that all contribute as it gets warmer to more and more water being transferred from the land surface and vegetation into the atmosphere as it gets warmer. Another way it does this is that the growing season, because it's getting warmer, right? The growing season is getting longer. Spring is starting earlier and fall is lasting longer. So the plants are able to photosynthesize for a longer period of time. That means the evapotranspiration is taking place over a longer period of time, and more water is being transferred from the plants and soil into the atmosphere over a longer period during the year. In the West, generally, the growing season has increased by 6 weeks already due to climate change. And those of you who go hiking in the Sierra Nevada know, or probably witnessed, that in some places, trees and plants are growing higher up in the mountains. So more photosynthesis there, more evapotranspiration there. Less water is getting into the rivers because it's getting taken away by the atmosphere. Okay. This is the challenge of something we call hot drought. And we talked about hot drought just as we started to realize it's going to get bad. And now it's really obvious that it's occurring, and it's having devastating impacts. So let's talk about those devastating impacts. But first, let's talk about what the drought looks like now. This is a recent map. Every couple of weeks, the government, the US government, NOAA, the National Atmospheric and NOAA, the National Atmospheric and Oceanic Administration. It's called the Ocean and Atmospheric Administration. This is horrible because I used to work for NOAA. So forgive me. They work with scientists and just observers across, and many of them at universities across the whole country. And they produce this map. Where are the drought conditions and how bad are they? And they can do this with satellites too, and then you get a general agreement. And what you can see here is the drought looks pretty bad in a lot of places, including California. This is a drought that's been lasting since 1999. It's the first mega drought we've witnessed in North America since we started measuring rainfall with rain gauges. As I'll mention later, these kinds of mega droughts, a mega drought is by definition a drought that lasts 20 years or longer. These have occurred before, and we know that from tree ring records. But this time, the mega drought has been caused not just by precipitation deficit or lack of rain and snow, but by these warmer temperatures. And what's interesting right now is not just that the drought's continuing in the West, but it's creeping out on the high plains. And you can see in this set of maps that it's done that before. So in 2002 and 2004 were really bad years for this drought. I'm not including some of the worst years for California, but I just wanted to show that the drought moves around in time. But it's always there. In particular, it's always there if you live in the Colorado River Basin or you live in Arizona. In 2012, you can see the drought was out looking like a Dust Bowl drought. That was the prior to this drought, the Dust Bowl drought of the 1930s. If you've read John Steinbeck, Grapes of Wrath, that describes what it was like out on the high plains, why everyone moved to California there during the 30s to get away from the horrible Dust Bowl drought of the high plains. Well, 2012, it was pretty bad out there, and it looks like it's getting bad out there again. And in the 2013, it was really bad in another part that was affected big time by the Dust Bowl years on the panhandle of Texas, Oklahoma, and New Mexico. This is a study that was done recently by one of your fellow Californians, Park Williams, who's now down at UCLA. And he and a bunch of colleagues did this really fascinating work where they first looked at the drought, and you can see the area in the map on the map that is got the word observed on it. That's what the drought looks like. So you can see that the drought was over the period from 2000 to 2021 was really bad in the eastern part of the West. So that's where the Colorado River Basin is, from Wyoming down into Arizona. It was also bad out in California. Okay. And what they did in that yellow box is they used tree rings to reconstruct soil moisture change, not just for the last 100 years, but for the last 1,200 years. And that's what's in that time series on the left part of the slide. This is a tree ring reconstructed soil moisture variation, and it's in standard deviation units. So when it's high, a positive number, that means it's wetter than normal. And when it's negative, it's drier than normal. And you can see in red the observed drought, and you can see in black the tree ring reconstructed drought. And where they overlap, they agree. So the 1920s were very wet. And we had some wet years more recently. But then starting in 1999, the bottom just fell out, and that red line goes down to the big horizontal line that is the 2000 to 2021 anomaly level. And it's now drier than ever before in that Western region than it's been in the last 1,200 years. And we've had multiple 20-year-long droughts. They're all shown by pink vertical bars. But the current drought is worse than any of the prior droughts. And then they do this analysis to look at what would the drought look like without climate change, anthropogenic climate change, ACC. You can see that on the far right map. That's what the drought would have looked like, far less severe, had we not had the warming and the drying due to anthropogenic climate change, due to the fossil fuel burning. And they conclude about 42% of the current drought, in other words, what made a sort of a bad drought much worse, is due to climate change. So this is a fundamental study, a very good study. We'll come back to that in a second. Why do we care? Well, the biggest thing going on in the West, you could argue if you're from California, the water shortages, the wildfires, everything going on in California is pretty dire. But if you want to see even worse situation, go to the Colorado River Basin or the Rio Grande River Basin. In those basins, there's literally a severe water shortage now. And the federal government has declared a water shortage for the first time in the Colorado River. The two biggest reservoirs in the country, Lake Mead and Lake Powell, are on that river. They're both less than a third full now. People's allocation of water is being cut by the federal government, particularly in Arizona and in Nevada. California has senior water rights. Those water rights mean that California is going to be one of the last states to be cut. And you'll see why that's important in a second. But this really dire situation, this water crisis, if you're in the Colorado River Basin, you can say there's a climate crisis for sure. You can say there's a wildfire crisis for sure, but you've also got a water crisis. And about half of that water crisis is due to the warming. Remember, we know exactly why that warming is occurring, and we know exactly how to stop that warming. And it's, of course, mostly due to fossil fuel and the burning of fossil fuel. Let's talk about the Colorado River Basin. Yeah, and it's Southern California is part of this basin. And depends on the water from this basin. Well, so do a total of about 40 million people in the West, stretching from Wyoming, not a lot of people up there, down into Arizona and California. And you can see on this map, the upper basin, sort of a lighter tan, and the lower basin, a darker tan. The upper basin is really critical. That's where the snow piles up in the winter. That's where the water comes from. This year we had about normal snow, a little below normal, but because of the warming, we're going to see a lot less of that snow get into the river as runoff. And instead, that water will go where? Into the atmosphere. Okay? It'll go via evaporation, mostly due to evapotranspiration, remember, from the soil and the plants. Sublimation, that is going to suck that water into the atmosphere and mean that the runoff won't be enough to really refill the reservoirs. Instead, they'll get lower. You can see all the cities that are in red. Some are not so big, like Cheyenne, but the others, everyone here will admit, are pretty big cities in the West. We have Salt Lake, Denver, Albuquerque, El Paso, Tucson, Phoenix, Vegas, Los Angeles. You probably heard of that place. San Diego. All of these places rely on water from this river. And eventually, if the flows continue to decline, they've declined 20% so far. If they continue to decline, there'll be a lot of problems with water supply. There'll be other problems. The economy of this region is about $1 trillion a year. Most of the vegetables we eat in winter come from this basin, particularly in southern Arizona and southern California. That agricultural productivity transfers to the Central Valley of California in the summer, but during the winter, it's all down there in the Imperial Valley, in the southernmost California. All that agriculture uses most of the water, depends on this river. A lot of native nations. It is all of Arizona's sustainable water supply, almost all. And it is now threatened by climate change in a very serious way. I wanted to let you sort of get a glimpse of why you should care in Northern California, which is technically what we say you are in Sierra College, is the water system in California is really incredible. What's incredible is, people in the West haven't really felt this drought nearly as bad as they could have because water managers, water engineers have been very clever in making sure that everyone had the water they need. And the only people who have suffered so far have been the farmers and the growers, the agricultural sector. What you can see on this map of California, and I'm not an expert on California water, so forgive me if I make a mistake, but down there in Southern California, you see the Colorado River Aqueduct, and you see the All-American Canal and the Coachella Canal. This is water coming from the Colorado River. And you can see it gets over to LA and it gets down to San Diego. Okay. So those places, when they have Colorado River water, are doing okay, but they're still asking for more water. They're desert cities. And the agriculture that's occurring down there in the lowest, next to where the All-American Canal is, just south of the Salton Sea, which is that water body that you can see down at the southern part of California. Those are all getting their water from the Colorado River. But they're all deserts and they need more water. And so they get water via the California Aqueduct. And they also get it from the Los Angeles Aqueduct. So water managers in LA were very smart folks. You can watch, there's some great movies about this. But they built these, they got a lot, back in the early part of the last century, they got a lot of water from a lot of parts of California as well as Colorado. So the water comes from Northern California. And if there's a drought in Northern California, they of course can't deliver as much water to Southern California. So we're all in this together. And unfortunately, right now, we're all in a drought together. And we all will start to suffer the consequences of global warming increasingly going into the future because our water supplies are going to be less and less and less. unless we stop climate change. Here's a picture just showing you the precipitation. It's essentially a measure of drought, SPEI, taking into account precipitation and temperature. And you can see in the red colors, we have severe drought, extreme drought over much of California. And it really, like I said, Northern Cal has been in an exceptional worst ever drought since we started measuring it this winter. And I want you all to ask yourself a question. Is this really a drought? That's not really fair of me to ask this question, but I'll tell you, I'll give you a hint what the answer is. Actually, I'll just tell you the answer. You know, prior to global warming, when we had a drought, say take the Dust Bowl drought, or take some of the droughts that have occurred in California last century, in the 1900s, the droughts occur. Everyone gets, oh my gosh, we have a drought. We better conserve water. We better do this. We better do that. But they all know the drought is going to end. And the thought experiment I want you all to do is to think, is this drought going to end? When is it going to end? And hopefully you've been listening to me. Always a big ask by someone giving a talk like this. Hopefully you've been listening and you realize as long as we keep putting greenhouse gases, as long as we keep burning fossil fuels and putting greenhouse gases in the atmosphere, it's just going to get warmer and warmer. And that means it's going to get drier and drier. This isn't a drought like of yore, where your parents, parents got to experience droughts. What you're experiencing is something called aridification. Others have called it desertification. So if you're down there in Southern California or parts of the interior Southwest, yeah, where you're living is going to turn more into a desert because you don't have enough rainfall. It's too hot. You're getting more evapotranspiration. And that will continue to get worse and worse until we stop global warming. Now, I'll give you a little bit of good news, and that is that as a climate scientist, I don't just study climate change caused by humans, but I study climate variability and change due to natural processes. And I'll bet you money that we're going to get some wet periods in the future. But the odds are stacked against wet periods more and more because of global warming, and they favor dry periods. So it's like getting dice that are loaded. It's like going to Las Vegas and knowing that if you bet on dry, you're more likely to win than if you bet on wet. And that's what global warming is doing to our favorite part of the country, the Southwest. And I'm going to show you that there are places like Michigan that aren't suffering this problem, but they're suffering a different problem. But let's wait for a minute before we get to that. So a number of us have completed studies, and we can say that if we let climate change go unchecked, as we are now doing, and great, California is doing a lot, Washington, Oregon are doing a lot to curb climate change. So are some states in the Northeast. Even Michigan is starting to do a lot. But as a nation, we're not meeting our Paris Agreement commitments. And that means if we continue to sort of be slackers on the climate action front, that means we could lose half of the water flows in the Colorado River and other rivers in the Southwest. Half. Maybe not as bad in the Sierra Nevada rivers, but we'll lose. You can bet on drier. You can bet on less flows. You can bet on more years like this year as it gets warmer and warmer. And if you're on the Colorado and you care about the Colorado River, you can bet on a lot less water. And as I tried to explain a minute ago, that means LA, San Diego farmers in California are going to be demanding more moisture from Northern California. So even if the crisis isn't as bad up there where you're at, the folks down south are going to be saying, I need more of your water. And you're going to probably end up giving it to them. So everybody will suffer. What's the big deal? Peck is here talking to you about the effect of temperature. And up until a few years ago, even some climate scientists were like stopping me at this point and saying, Peck, not a big deal. Some of the models that we use to project into the future, they all say it's going to get hotter as long as we put more greenhouse gases in the atmosphere. Some of those same models will say it's going to snow more, it's going to rain more. So, that'll compensate for the higher temperatures. What do you say to that, Peck? Well, what I say is don't bet on it unless you're kind of crazy. There hasn't been any increase in precipitation. As many models say it's going to get drier as say it's going to get wetter in terms of precipitation. Mother Nature is saying it isn't going to help. The bottom line, don't bet on more precipitation. And I'll go one step further. And I'll say it doesn't even matter because the Southwest, including California, is mega drought country. Remember this graph from Park Williams, the UCLA guy, who with his colleagues reconstructed soil moisture for the West using tree rings going back 1,200 years. There it is again, the time series. Each one of those vertical pink bands is another 20-year-long megadrought. Some of them obviously lasted longer. Look in the 1100s. Okay. Point is that we're going to continue to get periods of below normal precipitation, even if climate change gives us more precipitation. So let's say we luck out and all of a sudden we get periods of wetter conditions, like we're getting in Michigan. You're still in the Southwest going to get droughts. And during those droughts, you're going to get the precipitation droughts. You're going to get the full effect of the temperature. They're going to be more severe, more nasty, more costly. You pick the adjective. It's going to be bad, and it's going to only get worse and worse as it gets warmer because you're in mega drought country. The worst mega drought we've seen in the Colorado River Basin is 50 years with one normal year. One of my grad students working with Connie Woodhouse went even further back in time with tree rings, bristlecone pines. You might have heard of really long-lived trees that when they die, they just sit up there above tree line. So you can go way back and reconstruct drought. And the longest drought we've seen is about 50 years with 1 year of normal precipitation. Over near Mono Lake on the other side of the Sierra Nevada from where you're at, some of my colleagues think they've reconstructed a drought that was when Mono Lake was much drier. That was over 100 years in the Sierra Nevada. We're certainly in mega drought country. Yeah, oh my gosh. It's horrible. So that's why, oh, well, wait, there's more. The Missouri River Basin, so we're now up in Montana and Wyoming and out onto the high plains. It's also in the worst drought it's seen in the last 1,200 years. So that's why Brad Udall and I wrote a paper a couple of years ago talking about this is not about a drought of yore. It is not about a drought like your parents and grandparents experienced wherever they were living, as they probably did. This is aridification. This is something that we are causing. This is something that we can stop. Okay. And right now that drought is moving out on the aridification is moving out onto the high plains. And just to remind you what the worst year of the drought looked like during the Dust Bowl, there it is, 1934. This is when a heck of a lot of people moved to California. And read The Grapes of Wrath. There are other books that really describe viscerally what it was like for these poor folks, who now, of course, are, their descendants are, maybe some of you are descendants of people who moved to California back then. A lot of people are moving from Mexico as well, where the drought will also be very severe. Right? They'll be moving to wetter places. They might not be moving to California anymore because California will be really hurt by this drying out too. But Where will they move? And there are these things called flash droughts that are starting to occur more and more, where you use the minute the precipitation stops because of the heat being so darn bad compared to the way it used to be, you get an immediate drought, and it gets a lot worse really fast. And this is really rough on farmers and growers, particularly out in the high plains where we're starting to get these. The breadbasket of North America. We're starting to get more of these flash droughts. Never really happened before, but because of the warm temperatures, it is. So where are we going to get the water, everyone asks? Well, probably by now, I hope all of you are like, I'm going to talk to my mom and dad. I'm going to talk to everyone I know. We got to stop global warming, and here's why. The scientist from the University of Michigan has really spelled it out pretty clearly. I hope you understand. We got to stop global warming if we want to have the water we need into the future for your kids, my kids. Where are we getting the water now? The ground. We have a lot of water underground. That's great. It's like a natural buffer. This water is accumulated over millennia, literally over thousands of years during multiple cool periods, cool wet periods that we've had in the past, glacial periods. And it's there for us to pump out and use for farming and other purposes. The only problem is that water is fossil water. It doesn't recharge on human timescales. So if you look at all these blobs across North America in this map, they're all being depleted now by pumping, all of them. There are some aquifers, smaller aquifers, and if you really want me to tell you where, I could. I don't know them all, but I know, for example, in South Central Colorado, there's the San Luis Valley. I spent a lot of time in that neck of the woods. It's surrounded by 14,000 foot mountains and lots of snow in winter, and it recharges. Most places do not recharge though. So once the water is gone, it's gone. So think about what it's like out there in the high plains, where everywhere they're pumping water for irrigated agriculture and their municipal uses, and sooner or later it's going to disappear. It'll be too costly first to get the water out, it'll be too expensive, and then literally they'll pay the money, it'll be gone. But it's not just about water, and every one of you know that. It's about soil drying out. We've talked about that. And this is just how in yellow, you see darker colors are more correlated with southwest temperatures. And you can see over the entire region, wherever you have warmer temperatures, you get drier soils. And that gives rise to death of trees outright in New Mexico, and now in parts of California. The drying has killed trees outright. There's some dead pinon pines in the Four Corners area. Here's some dead pine trees, I believe, in Southern California that have been killed by year droughts, hot droughts. And of course, you get more wildfires. And there's a strong correlation between the warming and wildfires. And these out of control fires are getting more, not just out of control, but just unheard of large, severe fires are getting more and more common as it gets warmer. And that will continue as long as we allow it to get warmer. Okay. So it is a climate change crisis, but it is also a wildfire crisis. It's a water crisis. It's much worse than just a climate crisis. So this is, remember I said, people are gonna be a little bummed by the end of this talk. And I'm getting close to the end. Thank goodness, right? I think it's really important for you to know about this and for you to talk about this. I have hope as a climate scientist. I have hope because I know, and I think our society knows how to stop the crisis, how to deal with the crisis. But it takes political will. It means getting out of the fossil fuel era and entering the clean energy era. You're in California and you're leading the pack on this. And I want to just take my hat off, if I had one, to you guys. It's not impossible. You're doing it. I think it's fantastic. You got to stop using fossil fuels for electricity. Got to stop using fossil fuels for transportation. You got to stop using fossil fuels for everything. And you use renewable energy, wind, solar, batteries. All of these things are getting cheaper and cheaper and cheaper because they're being made and marketed around the world, and that causes things to get cheaper. We have other solutions, hydrogen, for example, for some things that just need really warm, hot temperatures, industrial processes, maybe long-term, long-range aircraft as well. We have the solutions. This is why I have hope. Okay. I also have hope because, frankly, because of you and your generation. I still get choked up when I talk about this, because my kids are your age. I have a college sophomore son and a high school daughter. Okay. You guys, unfortunately, are getting the problem that we created and that my generation before my parents created. I'm doing whatever I can to figure out the solutions. I'm trying really hard. That's how I get hope, by acting, doing whatever I can to solve the problem. But I'll tell you, these climate marches, the demonstrations, the boycotting of banks that are funding fossil fuel projects, this is the kind of thing that is making the difference. We have to change, move the needle. We have to stop burning fossil fuel. And your generation is doing more to make that happen than any generation before it. So I just want to take my hats off to you and say, I have hope because of you. Here's another reason I have hope. Our politicians are stuck in the mud. They're taking money from fossil fuel companies. They're taking money from other special interests who want to maintain the status quo. People who are making money don't want to change things. Right now, anyone who buys gas knows the oil and gas companies are making more money than ever before, thanks to Vladimir Putin driving up the price. Putin gets $1 billion a day, I think, from fossil fuel revenue. And what's he using that money for? War. There's another reason to get rid of fossil fuels. But most Americans know that climate change is real and that we're causing it and that we can stop it. This is a great study done by, you can't see the attribution, but Google climate change in Yale. Oh, it's up at the top. Yale University, they've been doing studies of public opinion on climate change now for quite a long time, many, many years. And you can see on this map, the estimated percent of adults who support, it's based on survey data, regulating CO2 as a pollutant. The percentage of Americans, adults, who want to do something about climate change. And over the entire nation, the average is 75% of Americans. 75%, that's a big number. Only 25% don't want to do it. Why the heck aren't we doing it? Special interests, spending a lot of money and keeping things like people like Senator Manchin, who killed the Biden Build Back Better plan, from voting for that, okay? You look at California and the numbers are even bigger. You look at Michigan, the numbers are bigger. You look at Arizona, the numbers are bigger. Okay, so Americans support action on climate change. This gives me hope. Okay, only 7% of Americans now are dismissive of climate change. I think they're mostly Fox News commentators. I'm just joking. They're mostly people in one party of American politics who probably get a lot of money from fossil fuel. I don't know why they do it, but they're voting against their constituents. They're voting against people in the Southwest who need water and who aren't getting it because of climate change. I'm not talking about what's happening in Michigan, but here we're getting too much flooding because the atmosphere holds more moisture. It can dump more moisture. That's why these hurricanes are getting worse. They're more flooding. It's the same darn process due to the same problem. Ocean levels, sea levels are going up. They're flooding along the coast. And in Florida, they call it nuisance flooding. These leaders in Florida are dismissive of climate change, even though their cities are getting flooded and will get flooded a hell of a lot more if we don't stop climate change. More good news, why I have hope. about 24 states in the United States of America, including, and then Puerto Rico and the District of Columbia, are acting on climate change. Michigan is releasing its climate plan on Earth Day this week, climate action plan. We're trying to catch up with you guys, and we're gonna catch up because we're committed to carbon neutrality just as you are. The University of Michigan is going carbon neutral. Ann Arbor, the city I live in, is going carbon neutral. You know, this is taking off like wildfire across the country, and over 50% of our GDP, gross domestic product, is in these states. And sure, there are a lot of states that are not acting. I was really upset. My old former home state of Arizona, controlled by the party, the political party that doesn't want to act on climate change, even though majority of Arizonans do. You got to wonder. There's no fossil fuel industry in Arizona, and yet they still vote for fossil fuels. So I'm concluding now, and I have a picture here of one of my Great Lakes. This is Lake Michigan. We have 80% of North America's fresh surface water in the Great Lakes, 80%. But we're getting a lot of flooding. We're getting heat waves. We're getting tornadoes in winter. You know, it's not good in Michigan either. But more and more people will move here because it's better in Michigan than it is in many other states. Water security risks are rising rapidly around the planet. What I've talked about in the Southwest, it's equally bad in the Mediterranean regions, in India, in Australia. Many other parts of the country are starting to experience this. The Amazon. The West, the US West, including California, is being hit really hard. You guys are right at ground zero of climate change. It's clear what the problem is, and it's also clear what the cause is. We know it will continue to worsen as long as we put greenhouse gases in the atmosphere, as long as we burn fossil fuels. We have to adapt to this change. We have 1 degree C warming so far. A paper just came out last week. We're pretty much guaranteed at least double that amount of warming, even if we act as hard as Joe Biden wants us to, okay? Even if Congress gets their act together and actually enacts the legislation that he's put on the table, we're still going to get double the climate change we have now. So double the impacts. But that's a heck of a lot better than if we don't do it. Then we could get triple, quadruple the amount of impacts we've had so far. And that would overwhelm our ability to adapt to climate change. And that's when the real suffering begins, including in the United States of America. And of course, many of you know the real suffering has already begun elsewhere around the planet. Whole island nations are going to be submerged by sea level rise if we don't act. Places like the Horn of Africa are already in humanitarian crisis. Madagascar, another place, because of hot drought and because of the food shortages that are being caused by the war in Ukraine. These things are going to start to combine and cause real hardship around the world. So I want you to talk to everyone you know, talk to your family, talk to your friends, talk to anyone who will listen about climate change. That's what we all need to do. Obviously, we need to all vote to act on climate change, but we can't. This is your future. This is my future. This is my kids' and grandkids' future. We all have to start doing more. And that's where we get hope. Don't get despondent. Do something, because that gives you agency. That gives you hope. And with that, I'd just like to say thank you, and maybe we have some time for some questions.
Thank you so much, Dr. Overpeck. That was excellent. I really appreciate how you tied in, us being in Northern California, we're still being affected by the need for more water down south. So we're still being affected by the aridification of the West. So thank you so much for your presentation. And I'm going to open it up to questions. If anyone has any questions, you're welcome to unmute yourself and ask your question, or you can type it in the chat window.
I apologize for going a little long. I worry that means time to move on to another class.
no, this topic deserves the airtime you're giving it.
This was fantastic. Oh, wait, hold on.
Oops.
I think Chrissy is also leading a class as well while she's simultaneously Zooming on her own laptop.
Yes, all right, so we had terrible feedback going on. This was fantastic. Thank you, everybody in the environmental science and sustainability #1 lab class. Say hello. We've been talking about ocean acidification over the last few weeks and doing labs on ocean acidification linked to climate change. I would love for you to talk about, I guess, some of your favorite mitigation strategies, and looking at, we're going to have to adapt to climate change, but we also need to mitigate. And you mentioned, California, we've been doing some fantastic things, but looking globally, where do you see the best effort for us to focus on our mitigation strategies for climate change?
Sure. It's really about electrifying everything. And so we want to utilize the free energy from the sun and from the wind. And we are, what's really nice about those two sources, whether it's a wind turbine or a solar panel, is energy generated that way has just been plummeting, much as big screen TV prices have plummeted. That's what tech does. And it's now cheaper than fossil fuel energy. But we also need to do that with our cars. The problem with cars and other trucks and mobility on the road is we need to get out of the internal combustion vehicle era and switch to electrified mobility, electrified transportation, EVs. And that requires batteries. We now have the batteries. That's the good news. The bad news is they're still a little too expensive, but the prices are coming down very rapidly. And so that's why you'll start to see Ford and GM and other manufacturers of cars switch over almost entirely to EVs in this decade, as the prices get compatible at the car dealer with internal combustion vehicles. And over their lifespan, they're already cheaper because EVs are less expensive to maintain, and the cost of electricity is cheaper than gas. So those of us who can afford an EV can drive EVs now and save money over an internal combustion engine car or truck. But those majority of Americans still, can't afford to pay the high upfront cost. And that again is why Biden was trying to subsidize purchase of these EVs in his Build Back Better plan and in his other bills. And we need those subsidies to help everyone get involved in electrifying everything they do. There are a few things that can't be done via just electrification. Think of fertilizer production, think of long haul aircraft. We do have electric planes now, but we can't fly across the oceans with them. So we need fuel, and that fuel will likely be produced by hydrogen, and the conversion of hydrogen which is generated using renewable energy, not hydrogen produced with fossil fuels. We'll generate hydrogen with renewable energy, and then we'll convert that hydrogen into other fuels that can then be used in an aircraft or fertilizer that can be used on fields. And then there's also cement making and steel making and industrial processes that require hotter temperatures. And again, fuels from hydrogen will be able to provide that. So I think that's what you're going to see. I actually am an advocate of keeping nuclear power plants that are safe going if they already exist. I do not think we'll see a build out of new nuclear energy. The reason being it's much more expensive. Why spend the extra money? Also, we have no place to put nuclear waste as a nation. And it's not a good thing to have lying around, which is what we do now. We just leave it outside the nuclear power plant. So I don't think we'll see nuclear. I hope that's like real quick mitigation.
I think one of my students is typing a question into the chat box for you there,
Okay.
Dr. Overpeck. Are you getting anything yet?
Okay, is this the most credible sources claim that our actions this decade will determine what happens to our planet? However, many changes are aimed at 2040 and beyond, such as California's goal. Well, this is one of those, and everyone else can read the no, I'll keep reading it because probably can't everyone read the chat. However, many changes are aimed for 2040 and beyond, such as California's goal to reach zero emissions. Will the intermediate changes that happen between now and then be enough to curb climate change in our favor? That is an excellent question. And when I'm working, for example, with the governor of Michigan or at the University of Michigan to go carbon neutral, our carbon neutrality is going to come in 2035, 2040, on that time scale. Ann Arbor, our city, we're going to try and go carbon neutral by 2030. So that would be the ideal condition to go carbon neutral by 2030. Because you're right, it's the actions we have this decade that are most important. But it's not feasible for a number of reasons for everything to go carbon neutral by 2030. I think we might end up going carbon neutral everywhere a lot faster than we think because the prices are falling so quickly of these clean tech technologies. But the important thing in this decade is to drive our emissions down by at least 50%. And that's what the Biden administration set out to do. And some of that is being done via the bipartisan infrastructure bill that did pass. And a lot of it was being proposed to be done by the Build Back Better plan that did not pass because of Senator Manchin. And we need that bill passed because that will enable the country to go 50%, over 50% carbon neutral in our electricity particular, and also a lot of our mobility by 2030. And that puts us on the path we need to be on to meet our Paris Agreement commitment that would allow us and other nations of the world to stop global warming at 2 degrees above pre-industrial temperatures. We would like to be 1.5 degrees above pre-industrial, but 2 degrees is a lot better than 3 or 4 degrees. So that's, I would say that if we can just get a lot of action and get half of the job done in this decade, I would be a pretty happy camper. And I think we will avert the major disaster that will occur if we do not do that.
Fantastic.
Another student question.
Yeah.
Are there other nations who are leading the way on curbing climate change who we should look to as examples? Right now, it's Europe is leading the charge. Europe is doing more than any other, and it's not every nation in Europe, but the nations of Europe are really kicking ass on this topic. And, some of the countries there are ramping up their efforts just in the last 6 months because they also realize how exposed they are to I wrote an op-ed, I call it petro thuggery, to petro, extortion from the Russians. In other words, the Russians had set it up so Europe relies on their gas and oil in order to get the energy they need. And Europe was thinking, I'll use natural gas as a bridge fuel to renewable energy. Now they're learning firsthand what a big mistake that was. So Germany is going to go carbon neutral much faster. They're shooting now for 2035, I think. So they're leading the pack. And countries like Norway are doing amazing things. Unfortunately, Norway is still producing a lot of oil and gas. So they're also doing some amazingly bad things. But they are also adopting EVs much faster than any other country, showing how easy it is to do. They're also, utilizing hydropower like no other country on the planet. So look to Europe, but I think look to California, look to New England. States there are doing a great job. New York just a week ago concluded a deal to build a new high transmission line from Canada down into New York City from northern New York. So they're going to have a lot of wind turbines in solar powering New York City pretty soon. And I think Michigan is going to do amazing things. Their plan is, our plan has been out for review. I'm on the council that's helped produce it. I'm not going to take any of the credit, but I've seen it. And it's a very good plan. And we have a lot of interim goals. So we have goals that are in the 2020s, and we'll show people that we can get a lot done this decade, and in particular with mobility, but also renewable energy.
Looks like the ESS class has a question.
Okay.
Yeah, I had a question, and it's kind of related to a previous question that was asked, but if, let's say, in a perfect world, we were able to just completely reduce our emissions within 10 years or so, would we see global conditions improve in any way, or would it still kind of remain at the way it is now?
Wow. I should really be asking you that and see how what you're learning in your class, but it sounds to me as though you have an idea, which is really good. That's a good question. Unfortunately, the temperature at which we stabilize global warming, in other words, we stop global warming, is the temperature we'll then have for centuries, unless we take CO2 out of and other greenhouse gases out of the atmosphere, particularly CO2. The problem is that over 90%, well, there are two problems. You probably know that there are multiple types of greenhouse gases. There's CO2, there's methane, there's nitrous oxide, the chlorofluorocarbons. Those are kind of the big ones. There's black carbon, say from our wildfires, and mostly from fossil fuel production. Well, most of those will fall out of the atmosphere pretty quickly, decades at most. Unfortunately, the CO2 will not. A lot of that CO2 we're putting in the atmosphere, some of those molecules will still be in the atmosphere a million years from now. But the other problem, so they'll keep warming. They'll keep the temperature higher, where we stabilize that level. But the other problem is that 92% or so of the heat that we're trapping in the atmosphere with our greenhouse gases is going into the ocean. So your professor mentioned, ocean acidification. Well, that's due to the CO2 getting soaked up by the ocean, and that's acidifying the ocean. But you're also getting a much warmer ocean. That's why the ocean is expanding and causing sea level rise. But that ocean heating is also causing coral reefs to bleach around the world and doing other nasty things. But the problem is that as we stabilize, and once we stop warming the planet and the atmosphere tries to cool off, which it will do naturally, right? The heat will escape into space slowly but surely. The ocean will be there to equilibrate with the atmosphere. So the ocean will act as a radiator to keep the atmosphere warm for decades to come. So it's going to be really hard to cool the planet back down to pre-industrial. Impossible. But we probably will get some reduction in the temperature if we don't warm too much. And we're also starting to develop ways to suck CO2 out of the atmosphere. And the technology ways to do that are very expensive and energy consumptive. But we also have natural carbon sinks. Unfortunately, as you know, in California, many of our natural carbon sinks, such as forests, people talk about plant 1 trillion trees, that kind of thing. Well, it doesn't do any good to plant trees if they then just turn around and die because it's too hot, or die because there's a forest fire. So we're going to have to get much more sophisticated in how we do it. But I'll bet you 10 years from now, we'll know how to take more CO2 out of the atmosphere at a reasonable cost. And we'll start to do that. But the first job right now is to do what you said, which is let's stop climate change as fast as we can. We know how to do it. It's affordable. The costs over the long haul are less than the costs of letting it continue in terms of human lives and hits to the economy. So let's just do it. By the way, what else does fossil fuel do? I've already mentioned that fossil fuel burning, in addition to being number one enemy for climate, is number one enemy for, Vladimir Putin. We're just fueling his war by having fossil fuels. But the third thing it does is it creates air pollution. And over 1 million people, I think it is. I don't know the number. Was it? I always forget the number. I think it's 7 million a year around the world die because of fossil fuel pollution. And a lot of those people are in America. And the fossil fuel caused wildfire uptick, air pollution. That's smoke that you guys are breathing in the summer. You're going to get it again this year. Go inside, wear masks, don't breathe that smoke. It's bad for your lungs, it's bad for your heart, and it's bad for your brain. If you have parents, keep them away from that smoke. It's a precursor to dementia, and then they're finding out. So, fossil fuels are hurting us in many ways.
Thank you.
Here's a Michigan
Dawn.
alum. Can I read that one?
Yeah, go for it.
All
And
right.
then Dawn Ackerman has a question. I want to make sure we get to her.
Okay. Actually, I saw it. It's from you. But I'm going to go with the Go Blue. Michigan alum here. Thanks so much for the talk, blah, blah, blah. Since so many of our current problems are rooted in industry and policy, it almost feels futile to take shorter showers, turn off the lights. What are the most important things for us as individuals to be doing right now to affect change? I don't think it's futile to take shorter showers or turn off the lights. We have to change our way of thinking. And everything we do adds up. So do that stuff, but I think the more important stuff is Catherine Naheo just came through here. And if you haven't watched her talks on YouTube, do it. If you haven't read her book, do it. She has a very good point. And that is, we got to talk more about climate change. I emphasize that everywhere I go. And I already have done that today. Talk to people about climate change. Make sure they understand what's going on. Make sure they understand that you care and you want to do something about it. Make sure that they know that the best thing they can do is vote for people who are going to act on climate. We have the technologies. We have the solutions. We lack the politicians who are going to enact those. California's doing a little better than most of the rest of the country. So, maybe we got to get out on the road, talk to people outside of California. But let's make sure that everyone sees that California is doing, and you're proving to the world that you can have the best economy in the country and deal with climate change, because that's what you're doing. So talk about it and vote. So, it's not like there's no silver bullet with climate change. It's silver buckshot, people like to say. There are a lot of things we can do. Okay, what's the other question, Allison?
Dawn Ackerman has her hand up. Go ahead, Dawn.
Thanks, Allison. So you talked about the immediate need is to switch over from fossil fuels to electrical source of energy. And I'm curious for you to comment on and whether or how much we're taking into account the need for or the effect of manufacturing and implementing infrastructure as we make these switches from one industry to another, say for our energy source. So as an example, though, you mentioned cement, the manufacturing of cement, and it's critical right now that the energy source be changed from fossil fuels. But what about that next step about cement? Because cement is basically, the emissions of carbon dioxide with cement manufacturing is just huge. But when we compare these different types of industries and which one is lower, are we taking into account, from beginning to end of all of that industry? Or are we really looking at just energy usage? When
you got to do the whole supply chain.
You do.
You're absolutely right. And for those of you who are kind of into this, there are multiple, we call them scopes of carbon emission. Scope 1, which is the energy that we produce and the carbon footprint associated with that energy. There's scope 2, which is the energy that we purchase. There's scope 3, which is like everything else. And Scope 3 is the hardest one. But a lot of what we buy, say on Amazon or, from China, we want that to be carbon neutral too. And fortunately, China is one country that is acting on climate change pretty aggressively. And I think the reason they're doing it is because they have a climate change problem just like we do. But they also realize that if they are the ones who are selling to the markets of the world as the whole world decarbonizes, China will get rich. So they want people to buy Chinese cars, not American cars. And Chinese everything, not American things. So this is a huge market, and they see a way to gain more market share by decarbonizing. So I think our supply chains will decarbonize. Let's just tackle cement, because I think you're raising a good one. About a quarter of our emissions are due to these industrial processes that are hard to decarbonize. And what are we doing in Michigan? We happen to have, because we're on the Great Lakes, really large cement plants. Because once you make the cement, you got to transport it, and that stuff's kind of heavy. And it's cheaper to ship it than it is to truck it. And so we have two of the largest cement factories in the country, right on the Great Lakes, one in Lake Michigan and Lake Huron. And what we're doing is thinking about ways to make cement that actually allows us to sequester carbon dioxide in the cement. So you need to emit CO2 when you make cement, but then if you can put the CO2 back into the cement in the way you make it, that's one way to cut the carbon emissions. Not a big way, 10% kind of thing. The other thing we're starting to do is the Biden administration, Department of Energy has already has announced it's going to fund a big hydrogen initiative. And Michigan is really, what we're looking at is co-locating our hydrogen. It's essentially a proof of concept hub with our cement industry and other industrial. We're an industrial state, unlike California. And so we have to figure this out in Michigan if we're going to decarbonize. But we're really looking at hydrogen made with renewable energy as the energy source for the cement manufacture. And of course, our goal is to figure out how to do that in an efficient way. And then our companies will be selling that to everyone. But obviously people will be able to use what we learned and do it themselves. They don't necessarily have to buy it from Michigan. So we're tackling that. I think other states will be doing similar experiments with their hydrogen hubs. There are going to be multiple hydrogen hubs around the country in the next year starting. The trick here is that earlier question is we really got to decarbonize fast. Industry will not be where we decarbonize fast. Whereas our electricity that we use for everyday things will decarbonize fast. Our mobility, our transportation will be decarbonized fast. Those are things that we already can do cheaper than with fossil fuel. And so you'll see that in this decade. And while we're doing that, we'll be, figuring out how to do the industry and agriculture. A lot of agriculture will also decarbonize pretty quick, but not all. And so we'll have to figure out these trickier parts of the puzzle while we're decarbonizing the easy things. And that again is why we're not going to go carbon neutral before, beyond 2030, but hopefully we'll go carbon neutral before 2040 or 2035. That's what I'm going to guess is by 2035, the United States will be largely carbon neutral, and Europe for sure. And I think it's going to be driven mostly because it's just going to be the cheap option. Market is going to make it happen. Right now, we need policy to get off of all these, fossil fuels we subsidize. It's crazy. We give the fossil fuel industry billions a year. And so we have to stop doing that because they're able to keep going because we're making them cost effective. Remove those fossil fuel subsidies, and all of a sudden everybody's going to go faster to renewable energy and electrified mobility.
Thank you.
Yep.
All right, I think that about wraps it up. That's the
Cool.
end of the class period, so I imagine people need to shuffle on over to their next class. But I just wanted to thank you so much, Dr. Overpeck. This was really fabulous, and I think you really got your message through to those of us who were in attendance. So thank you so much for taking the time. We really appreciate it.
Well, it's wonderful to talk to you all, and I hope you have a great Earth Month. I think it's worth celebrating for a whole month. So I really congratulate Sierra College for doing that. And it's a real pleasure. Take care and fight like hell for climate action. Okay. Bye-bye.
Will do. Thank you. Take care.